I'll just start now. So quick reminder, projectiles. So the two things we care about is the angle, the velocity, the speed that the particle is fired at, and the angle to the horizontal. What we do every time we have one of these questions is we're going to take that velocity v, and we're going to split it into a component that goes horizontally, that'll be v cos theta, and a component that goes vertically, that'll be v sine theta. And then what happens is that we actually consider the horizontal and vertical case separately. So UVAS and T subscript Y, UVAS and T subscript X. So a few things that we can say: that gravity is only happening in the vertical direction. So gravity here is 0. Another thing here is when we're at the top of our journey here, Vy is equal to 0. And we have a time which we call TGH. When we're here, the time is equal to 2 times the time to the greatest height. Okay. We also have that Vy is equal to minus Uy. We're going to use these formulas here. And then for this one here, we always have that S is equal to Ut. Sx is equal to Uxtx. Okay. So we don't have to worry about the acceleration component there. Okay. So let's get into some of the more tricky questions. Okay, so this is a bit of a warm-up. This one we had last week, or we didn't have this one last week, but one very like it last week. So a particle is projected from the top of a cliff with an initial speed of 40 meters per second. And the cliff is at a height of 30 and it's going off at an angle of alpha. Okay, and then the maximum height that's reached by the particle is 42. And then it strikes the ground at this point C, okay? So we want to find that value of alpha. We want to find the, so let's start to fill in some things to begin with, okay? So this here, that line there, I'm going to call that 0. I'm going to call this point here, I'm going to call that like, so let me just do, continue this up. Here we go. So more people are joining now. Okay, so for everybody who's joined, I just did a quick refresh on this page here, and now I'm on to the first question, okay? So a particle was projected at speed 40 from the top of a cliff again. The cliff is of height 30, and it goes off at this angle alpha. It gets up to a maximum height of 42 before striking the ground at C. We're asked for that angle alpha. We're asked for the horizontal range, which is going to be this distance here. Oh, sorry. 1 second, something's going on here. So we've been asked for, sorry, this one here. This here, sorry. So we've been asked for this height here. We're going to call that height, so that's 42 meters here. That height there. Okay, and then we've been asked for this horizontal range. Okay. So I'm going to set this here to be, have another person joining. Okay, so similar question to what we had last week. We're starting from the top of a cliff. We get projected at speed of 40, 30 meters up. We get to a maximum height of 42 meters, and then we land at C, and we're asked for alpha. We're asked for the horizontal range, that distance there, and we're asked for the speed of the particle as it hits the ground at C. Okay. All right. So what I'm going to do in this question is I'm going to say that the top of the cliff is not plus 30 meters, but is actually at 0 meters. The maximum height here is not 42, it's 12. And where it hits the ground here at C is actually at minus 30. Okay, so now what I'm going to do is I'm going to start writing down what I know. So the next thing I'll say is that this is the angle alpha, and this is the speed 40 that the particle is projected at. So that gives me the horizontal component is 40 cos alpha, and the vertical component is 40 sine alpha. So with that, now I'm going to write down u, x, v, x, a, x, s, x, and t, x. So that'll be that'll be 40 cos alpha. This will be also 40 cos alpha. This will be equal to 0. We don't know what that is. We're after that, right? We don't know what this is. So that's the horizontal component. Now the vertical component. So uy, vy, ay, sy, and ty. So obviously ay is equal to minus g. Minus because basically by sending the particle upwards, we impose that that is the positive direction. So we basically set that that is the positive direction in the, okay, 40 sine alpha is that one there. And then, okay, so let's start to write in what we know. So first thing is that we want to get this alpha here. So we're after the alpha. Okay, and what else do we know? Well, if it starts off at 0, so if its initial height is 0, then the height that it gets up is 12. So I'm going to say that this one is equal to 12. Okay, and also there at that maximum height, that v is going to be equal to 0. And from this, I'm going to be able to say that, just take this stuff here. So what have I got? I've got u, v, a, and s. So I can use v squared is equal to u squared plus 2as. I'll see what I get there. So 0 squared is equal to 40 sine squared, 40 squared sine squared alpha. Let's make sure I'm doing this correctly so that I'm not. Okay, yeah, so I can get actually a this way, but I think I'm doing it in the wrong way. I think it's going to actually end up giving me a little bit of a. So what I'm going to do is that'll give me a little bit of a headache. It will work, but it'll just be a headache. So what I'm going to do is I'm going to say that the horizontal range of the particle is equal to Sx is equal to u 40 cos alpha, and we'll call this then t. Okay, so we'll just say that first of all. And then at the same time, I can write, so I'm just looking at the solution here. So okay, sorry, I'm made 2 false starts. Let me do this correct again. Okay, so let's look at this here. I don't know the t, and I don't know the alpha. Okay, so straight from here, I can say that v is equal to u plus at could be a formula that I can use because I've got v, u, a, and then I don't know. So that will have, when I construct this equation, it'll have those two unknowns in it. And I can also say that s is equal to ut plus a half at squared. Okay, so this is the first one and this is the second one. So let's have a look at the first one. Okay, so v is equal to u plus at. 0 will be equal to 40 sine of alpha minus g times t, which gives me g times t is equal to 40 sine alpha, which gives me that t is equal to 40 sine alpha over g. So that's the result from the first one. And the second one, s is equal to ut plus a half at squared. So when we get up to that height there, that's 12 is equal to u 40 sine alpha times that same t, but that, yeah, 40 times, then minus a half times g times t squared. However, the t was equal to that stuff, right? So that's the same then as, that tells me that 12 is equal to 40 sine alpha times 40 sine alpha over g minus g over 2 times 40 sine alpha over g, all to be squared. The way I started in the beginning would have worked as well, but I'm keeping close to the solution here. So So I'll have something to reference. So what I did was just from what information that I was given here, like I'm always going to like use like either this one, or this one. And it's pretty like you can use any of them, right? Like sometimes I guess I maybe try to avoid using that one because of the squares, perhaps. So I could just see that actually from here I have this, I already have V, I have S, and the things I don't have are this A and T. Oh, sorry, I have A, sorry, this U and this T, but I can get two equations basically in the U and the T, basically, okay? And then I end up with this T here in terms of the alpha, and then this equation has an alpha and a T in it, but then I can sub in. So now I just have an equation with just alpha in it. Okay, so now that's 12 is equal to, this is 1600 because of the 40 times the 40, then it's like sine squared alpha over G, and then that's minus, so that's going to be this G will cancel with one of those G's, so that will be 1 over 2 times G times 1600 sine squared alpha. Okay, so I've got 12, and then I have 1600 is here and here, and I have over G, and then that's like sine squared alpha minus sine squared alpha over 2, which is going to be, this is going to be 12G over 1600 is equal to sine squared alpha over 2, because that's sine squared alpha minus sine squared alpha over 2, right? So that's like 2 sine squared alpha over 2 minus 1 sine squared alpha over 2. So I multiply that across, I've got 12 over 800. G is equal to sine squared alpha. This gives me, this 12, it's like 4 will go in there, it'll be like 3 times over, 4 goes in there, 200. So 3 over 200 times G is equal to sine squared alpha. And then this ends up giving me, when I put it into the calculator, a sine alpha is equal to, sorry, a alpha is equal to 22.5 degrees. Okay, and then we're asked about the horizontal range of the particle. Well, now that I have alpha, I can get t. So now t is just what it was. So t is equal to sine, 40 sine alpha over g. So that t is equal to 40, then sine times sine of 22.5 over g. And that, whatever that gives me, I don't know if it's there. So the speed of the particle as it's squared. So then, oh yeah, sorry. Now we want the, sorry, that's, so this is not giving me what I want here because that t is for there, right? So let's just go back to the question again. So now this alpha here is 22.5. This is 22.5. And okay, and we're going to look for the horizontal range of the particle. So what's the horizontal range of the particle going to be? Well, for the horizontal range, let's go to a new page. I'll just take this across because I think we'll need it. Okay, so for the horizontal range, let's just write out what we know again. So ux, vx, ax, sx, and tx. uy, vy, ay, sy, and ty. First, okay, so this is ay is equal to minus g. And what we want is we want to get the horizontal range. So we need sx is equal to ux times this tx here, which we'll just call t. This is a different time to the time that we found the last time, because the time that we found the last time was the time there that corresponded to the greatest height. And this isn't, I said before that like like when you get to the top, that's TGH, but that's time to the greatest height. And then when you get to the bottom, then it's like, that's only the case if you end up being back at the same height again, right? Here we're way down, so we don't know what that time is there. So, okay, so that's Tx is equal to T. So we need to find out what that T is then. Okay, so we look at the other one. So we look at this here. So what do we know? Well, we have an S, we have a U, we have an A, and what we don't have is that T. So I can use S is equal to UT plus half AT squared. Then I'll get minus 30 is equal to 40 sine 22.5 minus G over 2 times, sorry, that's times a T, then minus G over 2 times T squared. All of this here is going to give me T is equal to 4.49. I'm just reading it off the solution. So how you would get that is you would have to do the quadratic formula, right, to get out that value for T. And now we can sub this value in here. So that's going to be, the range is then going to be equal to, it's going to be X is going to be equal to 40 cos 22.5 times that 4.49. And the final piece here, which is a kind of like new piece, I guess, for this one here, is that we're looking for the final velocity when it strikes C. We're looking for that velocity there. Okay. So when we look for that velocity there, it's going to be made up of a horizontal piece and a vertical piece. And this horizontal piece here, it's going to be this one, 40 cos 22.5. And this vertical piece here, it's going to be this one. So after we get out what T is, now we can go over and we can find V by doing V is equal to U plus AT. Okay. So what we're doing is we're using these three formulas over and over and over. We're laying out our information. We're figuring out what we were being asked for. And then basically, like, well, I could have used V squared is equal to U squared plus 2AS. That would have given it to me. Whatever way, whichever formula or combination of formulas that you use is fine. It'll probably work, right? Once you pick one that you have, like by picking these two here, we ended up getting a simultaneous equation. So we could get our alpha and T out of that. And then once we had that for the first one, then also what was really crucial is like for this part one here, we were actually here at the greatest height, right? But for part two, we were down here. So we had to kind of connect the which question we're doing to where we are in the diagram and therefore pick out the right numbers for that section. Okay. So, okay, let's just move on and get going on a new one because that was a little bit, got bogged down there a little bit. Okay. Okay, so a particle is projected with a speed of the square root of 9gh over 2 from a point P at the top of a cliff of height h, and it strikes the ground a horizontal distance 3h from P. And it says find the two possible angles of projection. And then for each angle of projection, find in terms of h the time it takes for the particle to reach P. Okay, so what's that? Okay, so let me draw this first of all. Now, if you're wondering why it's this, probably everything's going to cancel out at the end really neatly. Okay, so I'll do my H. Okay, and then we'll do a distance 3h out. So it strikes the ground here at this point P, and then that distance there is like 3h. And the particle takes this trajectory here like this, something like that, right? Okay, go. Okay, so what do we know? So we know that the initial velocity is, do that again. The initial velocity is 9gh square root of 9gh over 2. We need to find the two possible angles of projection. So let me just do like this, alpha. And probably like the second one might be, the second one might even be a negative one, right? Okay, so, but it doesn't matter. We'll just draw like this and then we'll end up getting two answers out and we can interpret that afterwards. Okay, so that's immediately going to give us square root of 9gh over 2, and then the angle alpha. And this is going to give like the square root of 9gh over 2 times cos alpha. A lot of this is just sort of keeping your head while you're writing down like these sort of 9gh long expressions, right? So, okay, and then we have that, we're going to call this, this will be like 0, right? This will be minus h, and this is 3h. So let me just fill in what I know, and I'm going to consider this point here, right? So what do I know about, let's say, when we get to that point there? So ux, vx, ax, sx, and tx. Okay, and then uy, vy, ay, sy, and ty. Okay, so let me just get this one here. So that's going to be, so that's there. This one is here. Okay, so what else do I know? So I also know that they're equal to each other. This is 0. This is 3h. That is minus h. This is minus g. And the final thing is that we'll know that we'll have the same time in both. Okay, so maybe I'll just take all of this to the next page. So kind of like, here when I'm at this point, I'm kind of done maybe with the diagram because I kind of have everything I need. So I can sort of maybe start like sort of fresh in my head. Okay, so the first one, what do we have? So we have like what are our unknowns? Well, we don't know what the alpha is. We don't know what the t is, right? But we can write down that like I know we also don't know what the h is, right? But we have a h over here too, and it's probable that they'll sort of cancel out. But we'll see what happens, right? So let's say 3h is equal to, so it's going to be s is equal to ut, right? So that's going to be 3h is equal to the square root of 9gh over 2 times cos alpha times t. And so that tells me that, yeah, so that tells me that t is equal to 3h divided by the square root of 9gh over 2 times cos of alpha. So pretty long, okay? So what can we get from the second one? So from the second one, what do we have? So we have the S, we have the U, we have the A, and the thing we don't know, again, is the T. So these are like the unknowns again, okay? So here I can go over and write out, now watch this now, S is equal to UT plus a half AT squared. So minus H is equal to the square root of 9GH over 2 sine alpha times T 3H over the square root of 9 GH over 2 cos alpha.
Sorry, for the y, do you not need two separate equations because the velocity reaches 0 before you fall back down, or can you do it all in the same?
Yeah, that's a good question. So basically what your question is, Sorry, what you're saying here is like, in some cases, sorry, I don't know why that popped up. Yeah, so in this question here, for the first part of it, we were able to concentrate on this maximum height one. And then in the second part of the question, now from the second question, what we're given is basically the information is only about the end. We're not told anything about that middle part, right? So what that would mean that is if we were to come in here and state that like this was zero, and this is basically saying that we're looking at that point then. But because we were told, okay, it strikes the ground at this point P, which basically has coordinates, the X value is 3H. So we've been already sort of told to look at that point there, basically. And so we're not going to look at this one here. So then when we look at that one there, what's true at this point here? Well, the UX and the VX and the AX, they will always be the same, you know, whatever it was at the start. Okay, this is true at that point, and the other thing that's true at that point is this is true at that point. And we actually don't know anything about that one just now, just already. So it's a really good point, because like in the middle of all this mess, you can actually kind of sort of like, we have been signposted to this point because of that number in this one here. That's why it's not obvious, right? But because we've been given the maximum height, it makes sense to put that in and consider that point. Therefore, a few other things would go from here. For example, Vy is equal to 0 would be another thing that we can say about that point, right? But then because this one, there was no mention of that, then it was like, okay, so I suppose I've made that point. Does that make sense, I guess?
Yeah, thanks. So.
Yep. Okay, so where are we now? Okay, so we're here. And then this is like, okay, so this is U, that's that one, times T, which is this thing. Okay. And then it's plus a half A. So A is equal to minus G. So that's like minus G over 2, and then T squared. So look at this here. The square root of 9GH all over 2 times cos of alpha, all to be squared. Okay, so it looks crazy. Let's just sort of start to simplify this. Well, the first thing that we can see is that we have like this 9GH over 2. It's here and it's here. So they go straight away. So we have minus H is equal to, that's that there. That 3H is left over. And then we have a sine over cos, so we have a tan. And then we have this minus G over 2. And then we still have this, what's going to happen here? Okay, so we have, I think we just have to square it all out. So 9H squared over 9GH all over 2. This happens a lot, like in applied maths and physics and stuff. You end up having these big long expressions, but just like keep your head anyway when you do it. Okay, so let's just have a look at what cancels out. So first of all, that 9 goes and that 9 goes. One of these H's go, this H here goes. This G goes with this G. And this 2 here is actually, it's actually 1 over 2. So that 2 pops up to the top and it cancels with that one there. So we have minus H is equal to 3H tan alpha minus H times 1 over cos squared alpha. Okay, so are we closer to solving this? Well, first of all, yeah, we can see that we can get rid of a H. This is going to be minus 1 is equal to 3 tan alpha. And let's have a look at this 1 over cos squared. We had the same one last week, right? So anytime you see 1 in an expression like this, like we're going to be able to, where is it? Somewhere here. You see cos squared plus sine squared is equal to 1. You just use it really, really a lot, right? So if we look over here, now why am I doing this? It's not like it's not exactly obvious why I'm doing it, but Okay, so that this one at the top can be replaced with cos squared alpha plus sine squared alpha. Okay, and then we have a cos squared alpha here. And then this becomes -1 is equal to 3 tan alpha. Like this splits here -1 and then minus tan squared alpha. I'll just show you why. Okay, cos squared alpha over cos squared alpha plus sine squared alpha over cos squared alpha. So this first one is 1 plus, and then this is sine alpha over cos alpha, which is tan alpha, but it's tan squared alpha. But then there's a minus outside, so it's minus both of them, okay? That minus cancels from there. And so now we have that tan squared alpha is equal to 3 tan alpha. And this gives us either that, well, tan alpha is either equal to 0, because we could have a 0 on both sides, or else we can divide across by a non-zero, so then either, or tan alpha is equal to 3. And this gives us that the angle alpha is equal to 0, or the angle alpha is equal to 71.6 degrees. Okay. And then the second part of the question is, for each angle of projection, find in terms of h the time it takes for the particle to reach p. Okay, so that might seem like a whole other endeavor, but we already have that t is equal to 3h, this thing, right, over the square root of 9 gh over 2 times cos alpha. So now we can sub in the two values. Either alpha is equal to 0 or alpha is equal to 71.6. Okay, so this is tricky, right? But let's just look at like why it's tricky. Okay, so the first thing about it is we just made a diagram, right? So we just told it's a cliff, it's projected at alpha. Like this has come up many times, right? These are already in our heads going to be sort of like the highest point, or when it hits the ground, they're going to be sort of points that we're going to take interest in. Okay, we split the velocities as we do every single time. Okay, then we just do this table and we do this table. We fill in the velocity, fill in the velocity, fill in the gravity, fill in the no acceleration. Then we read the question. Now, what does it say in the question? It says the cliff top has a height. This is a height h, and this here is a distance 3h. So what I've done here is I've basically set this to be the point 0, 0. So this is like the cross on the xy axis, which would make the point when it hits the ground, it would make that, well, 3h for the x value and minus h for the y value. And then suddenly now I'm in a situation where these two columns are mostly filled, and then everything else is just a horrible kind of tracking of symbols and doing it slowly until we get down to the answer. Okay. So let's try that same type of framework with the next question. So maybe take a little breather for a second. I think we've kind of done, this might be, should I do this one, or maybe we'll the next one is a little bit more kind of interesting. Well, I'll tell you, I'll just sort of sketch the answer for this question here. So we've told a ball is thrown from a point A. So there's the point A at a target T. It's thrown at this one here, which is on horizontal ground. The point A is 17.4 meters vertically above the point 0. Okay, so that's just like 17.4. And the ball is thrown from A with a speed 25 meters per second at an angle of 30 degrees below the horizontal, and the distance from here to here is 21. And it says the ball misses the target and hits the ground at the point B as shown in the diagram, and then find the time that it takes to travel. So let's just sort of like write some things down. So this is like, that's my 25 meters per second, okay? This is like my horizontal here, right? That's my horizontal. So I'll go over and immediately say that my velocity is going to be, horizontal component is going to be 25 cos, that's meters per second, just ignore that. So 25 cos of minus 30. And this one here is 25 sine of minus 30. Okay, so cos of minus 30 is going to be the same as cos of 30, right? So just, you see that cos of minus a is cos of a, but sine of minus a is minus sine a, right? So that's going to be, so we'll just fill in our ux, vx, ax, sx, and tx. uy, vy, ay, sy, and ty. Also, cos of 30 is equal to root 3 over 2, isn't it? So cos of 30, so this is 30 degrees, cos of 30 is equal to root 3 over 2, root 3 over 2, and sine of 30 is equal to 1 over 2. So that means cos of minus 30, this is the same as cos of minus 30 is also equal to root 3 over 2. And then sine of minus 30 is equal to minus 1 over 2. Okay, so this is going to let me say that this is equal to 25 times root 3 over 2. And this one is equal to minus 25 over 2. This is equal to g. Now, what's it talking about? It's talking about the point when it hits the ground, right? So that, let's take this to be 0. And so that will be minus 17.4. And this will be 0. And this is going to be, we have to figure out what this one is. Okay. Okay, so the time, so this is what we're after. This is what we're after here. Now, what do we have? We have U, we have A, we have S, and we have T. And the T is the only unknown. So S is equal to UT plus a half AT squared. So, oh yeah, and this is minus G. Okay, and there's another thing that I'm going to do here. I just want you to kind of just consider this for a moment. So if I write like S is equal to UT plus a half AT squared. So I'm going to say minus 17.4 is equal to minus 25 over 2 times the T minus G over 2 times the T squared. Okay, so what's the unknown? The T is the unknown. This is a quadratic. We can use a quadratic formula to solve it. But what I want to draw your attention to is these 3 minus signs. Because you see in this problem, like you see the particle is actually projected downwards. So what I'm going to do is just only for this question, I'm going to consider the downward direction positive. Why? Because I can, and it makes life easier, right? So that would be a plus then. But then gravity wouldn't be a deceleration, it would be an acceleration. And what I'm also going to do is I'm going to say that this is like a distance just being traveled. So I call that a plus 2. So it's just the exact same as canceling off the minus from all sides, but it's sort of interpreting the problem in a different way. And you'll find that actually a lot of the time, the way in which you interpret the problem makes life a lot simpler. So it's just a small example, but this is what we do all the time in physics and in applied maths, is like we choose to sort of view the problem in a way that's convenient for us in the way that we're going to go about solving it, right? So, okay, so from all this, the only unknown is T. We get the T out. And then once we have that T, you see, we're going to be able to work out, we'll sub that T in here. And then we're actually going to get like, you know, it doesn't land. We've been aiming. This is like, I don't know, some weird golf shot off a cliff or something. We're aiming for the hole here, and it's gotten to this point here. So we can work out B. So that'll just be, this will be, sorry, OB, right? And then we can just work out 21 minus that for the answer. Okay. So what I'm saying like over and over and over is that like when I look at this question here, you don't know how, no one knows how to solve this just looking at it, right? But what happens is that if you spend the page sort of like sort of accumulating the information that you have, then the answer is going to reveal itself, and it's always going to be of a standard form. And actually what's really important here is for us to kind of like, we're interested in like this point here. Like last time we were interested in like this point. So that's actually where the brain work has to happen in the interpretation, and the rest of it should just be the same method every time. Okay. Okay. So, so these ones are like, as I said, they are trickier than the ones that we were doing last time. However, it's sort of like what I'm trying to convince you of is that they are actually quite the same as each other, right? So you always sort of have the same way of, okay, so this one is a little different. It's a little bit more challenging. So a particle is projected from a point on horizontal ground with a speed u at an angle of 30 degrees to the horizontal. And the particle is at a height of 7.35 meters above the ground at the 2 times t1 and t2 seconds. And then we're told if t2 minus t1 is equal to 1.5, then find the value of u. Okay, so this seems a little bit different. So let me just sort of start to draw things. So we have like the particle being projected at an angle. This is like supposed to be 30 degrees. Just, it's obviously too big, but we'll just sort of, okay, so it then takes, sorry, it takes this trajectory. Okay. Okay, and then so then we have our height. Okay, now let's just say that's our maximum height here. We don't know what it is. And what they're saying is like that there's another height here, 7.35. And this is like T1 here. And this is like T2 here. And they don't tell us anything about it. This was a speed u at the beginning. But they've told us that T2 minus T1 is equal to 1 point. So whatever's going on, these times can only be 1.5 seconds apart. Okay? So do you know what I mean? Like you're kind of thrown into the wilderness and then you're given one piece of information. Okay? So let's go ahead and work on this. Okay, so let's first of all write down the two tables as we always do. So again, we're going to have like our u. You'll also kind of notice that as often as I can, that's 30 degrees. This is u cos 30. This is u sine 30. I'm kind of keeping like that bit there up in that corner. I'm keeping, you'll find your own way of doing it, but like kind of keeping it as like, your photographic memory won't remember like numbers or anything, but it will remember like layout and stuff. And as soon as you choose to kind of do it in the way that you always do it, it'll just trigger so much memory, right? So a lot of it is just about like kind of not like keeping the head, right? Just not panicking. And like I mean that like that's most of the time you actually get a feeling of like, oh, I don't know what to do here. Right? So it feels like panic, but okay. So now just again, like anytime I see sine 30, I'm like u over 2. And anytime I see cos 30, I'm like the square root of 3 over 2 times u, okay? So let's fill these in. This is the square root of 3 over 2 times u. This is equal to u over 2. That one will be equal to that one. This will be equal to 0. This will be equal to minus g. This time we have been projected upwards, so we're going to take that as minus. Okay, and what else? What else can we fill in here? So all we have are these 2 points here, and all we know about these 2 points is that the height is going to be equal to 7.35. Okay, so we have what do we have? We have and this question is also about finding like values of t, isn't it? So that is going to point me to this one. So I have a u, I have an a, and I have an s, and I have a t. Okay, so this is going to point me to s is equal to ut plus a half at squared. Okay, so now I have that 7.35 is equal to u over 2 times t minus g over 2 times t squared. And I'm going to get, what am I going to do? I'm going to bring everything to the left-hand side. So I have g over 2 times t squared minus u over 2 times t plus 7.35 is equal to 0. Okay, so again, I've just done all the same stuff I always do. I've drawn a diagram, I've done this thing here, and I've done these two tables, and then I have my and then I've looked at it. What do I have? Well, I have the U, I have the A, I have the S, and the T. So I made this is sort of redundant. I didn't have to write that down at all, but I didn't know that I didn't have to write that down, so I just wrote it down anyway. And then okay, then I can look at what I'm it's a question about T, so I kind of know that I'm after this thing here, right? And then if I look there, then I can see, okay, I don't know what U is, but I have information on those UA that points at this one, and then I just fill in. And actually, we're quite close to the answer now. So what do I do with this? Well, this here is a quadratic, right? I've got my T squared, I have my T, and I have my number. So now if I take this over to the next page, 1 second, over here. Just going to do a couple of little things. Like, for example, I see this 2 here. I'm going to multiply across by 2. So that'll be GT squared minus UT plus, and then 2 times this will be 14.7 equal to 0. Okay. And this is my A, and this is my B, and this is my C. And then my quadratic formula will be, well, we always have x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. If you're not sure about that, I think it's in the tables, but and that's actually not x, it's t. So that means that t is then equal to like minus b. So b is equal to minus u, right? So that's u plus or minus the square root of minus u squared, which is u squared, minus 4 times g times 14.7. I'll put that in brackets. All over 2 times a over 2 times g. Now you might be thinking, like, how is this getting us close to anything? Well, T1 is equal to u plus that stuff. Well, it isn't, is it? It's equal to T minus that stuff. I'll tell you why in a second. U squared minus 4 times, well, 4 times 14.7 is 58.8 times G all over 2G. And T2 is equal to U plus U squared minus 58.8 times G all over 2G. Now, the reason I'm saying that is because this U number is going to be a positive because it's going to be like the speed that the particle was projected at, right? And this one here is going to be, well, it has to be positive. If this is not positive under the square root, then the square root won't work. So, even though you can get the square root of a minus number, in this situation, it won't be a real time. So it's going to be positive. So this will be a positive number minus a positive number. This will be a positive number plus a positive number. And we just know that T1 happens before T2. So T1 has to be the smaller one. Okay, so that's why I made that one to be the minus. Okay, so again, you might be thinking, well, I don't see where this leaves us, but we do know that T2 minus T1 is equal to 1.5. So what does that tell us? That tells us that U plus the square root of U squared minus 58.8 times G all over 2G minus U minus U squared minus 58.8 G all over 2G, that's equal to 1.5. Okay, almost there. Okay, so what have I got on both sides? Well, I have a fraction, right? I've got a 2G on the bottom. I'm going to multiply across by that 2G. So I have a U plus the square root of U squared minus 58.8 times G minus all of that now. Okay, you have to be super careful because in the midst of all of this that you're going to make the mistake. And that's what happens most of the time when people make 1.5 times 2G, which is just 1.5 times 2 is 3, right? So that's 3G. Okay, so what happened was that this was minus times the u is a minus u, but the minus times a minus is a plus. Okay, so the u's cancel, and I've got 2 times the square root of u squared minus 58.8 times g is equal to 3g. The 2's cancel goes over here, and then u squared minus 58.8 times g is equal to square this side 9g squared over 4. And now I'm going to see I've only got one unknown. The u squared now is equal to 9g squared over 4 minus plus 58.8 times g. And then I'm going to get basically u squared is equal to 792 now I'm just like throwing stuff into the calculator. So 792.33. So u then has to be equal to 28.15 meters per second. So again, it's like this bit was the same, right? This bit was the same, and this bit was the same. And then it's sort of like, okay, well, what do I have? Like, what am I after? And this is more about your intuition, because if you go wrong here, you'll just delay yourself, and you'll have a false start. You'll have to try again, then you'll lose confidence, stuff like that. So it's just sort of carefully think about what direction am I going to go? And it's like, well, what am I after? I'm after time, and like I already have these things. So it's just s is equal to ut plus a half at squared. Then you get to here, and it's like, how do you like, because if you were wrong about that, you put all these 2 pages in, and it could be a bit blind, right? And the answer I can give you there is that, like, with a lot of practice, basically, and like, obviously practice where you have the solution and you can kind of test yourself, you're kind of like I would have my doubts about this, but then I'd be like, well, what else could I do? Like if you look at, there isn't much given in the question. And when there's not so much given in the question, there's not so many different ways that you can go, right? And so it's sort of like there isn't any other way, so it must be this way, right? And then you just got to go with it, right? And then like you'll get, if you don't have that feeling of like doubt and thinking that you're going wrong, you'll get much further than you will than if you're thinking like, oh, this can't be right, because it ends up being a big page of sort of calculation. But this stuff here is just, it's sort of weird, because like just naively, if anyone was like not doing applied maths and wasn't good at maths and was listening to this class now, they would think this is the hard page, right? They would think this is all the hard stuff. But this stuff is just kind of like, you're not even really kind of thinking, you're just being careful. Okay, so it's much more methodical. The hard bit is mostly kind of here, in my opinion. It's kind of knowing like, okay, and it's also kind of like the 2 different times. Okay, like how will we get like how will we get 2 different times? Why would 2 different times come up? And it's like, okay, it's 7.35. The particle will go up past it, will come back down past it, right? But then, so that's how we can get 2 times out. But like, where can 2 different times come from? Well, they can come from a quadratic. And which of those, like, which of these rules is a quadratic? It's that one. So you see what I'm saying? Like the more kind of familiarity you have, it's sort of like each time, like you're just getting more and more sort of confident each time. You're like, okay, 2 times, probably it's that formula. There isn't really anything else. Okay, so what would I know about that? Well, I know this one, I know this one. Okay, I got to here. And by the way, if you're already here doing work in here like this, you're gonna get 7 out of 10, even if you foul this up completely, right? Like, because you're definitely on the right path. And like in applied maths, we don't really like this sort of stuff. Like you see me sort of like just sort of like rattling it off in the end. Like we don't really care about the number. We care much more about the method, right? Okay. So so I hope that it's not too intense and too overwhelming, and I hope that you can kind of agree that I can use somewhat of the same kind of procedure each time for each of these different questions. Okay, so let me just I'll just do one more real quick, because I want to move on to a different topic next week, unless people want to. I guess I do probably, so there's about 10 topics, and I did 3 on the first, we got the first one out of the way. So I'll do like, it's about 9 more topics kind of thing. I was thinking about doing like 2 weeks per topic, but like we can always spend the next 2 weeks, so we can go back at any point. to do more. So just in case we were not going to continue, like I plan to go into connected particles, I think next week. So I just want to start on this one here, not finish it, but just sort of like talk about this one. And okay, so let's think here for a second. So we have two balls P and Q that are projected into the air from the points A and B. So we have the point A and we have the point B. And they're a distance d apart from one another. And it's along the horizontal axis. The motion of the balls may be modeled as a projectile motion in the vertical plane, ignoring the effects of air resistance. Okay, so this one here is projected at t is equal to 0. This ball A that's projected from P is projected at t is equal to 0, with an initial velocity of 38 meters per second at 41 degrees to AB, and then Q is projected from the point B at the time 1, with initial speed is equal to 64. So let me just do some things. This will be 38, 41 degrees. So this immediately gives me 38 cos 41, which will be a number. I think we can put it probably straight into the calculator. 38 sine 41 will be the second one. That's for A. And then we have for B, we have, it goes this way, doesn't it? Probably goes this way. 64 degrees, then it's going at U. So this gives me immediately a like minus U like cos 64, and then going up, it's a U sine 64. Okay, so what I'm going to do is have an A here. I'm going to have a B here. I'm going to do my U, V, A, S, and T off of the X. My U, V, A, S, and T off of the Y. U, V, A, S, and T off of the X. U, V, A, S, and T off of the Y. Fill in what I know. Okay, so this is 38 cos 41. This is 38 sine 41. This one here is a 0. This is a minus G. This is equal to 0. This one is equal to minus G. Okay, now this one here is equal to T. This one will also be T. For B, it was fired like 1 second later. So the first one, T was fired at 0. But the second one is fired T is equal to 1. So it's the same time, but it just has 1 second less. Okay. And let's call the distance between these like D. So, and let's say that they, they're going to, okay. So the question is going to be like basically they collide after 3 seconds. So this one here is going to be equal to 3. This one's equal to 3. This one's equal to 2. This one's equal to 2. So, and I'm just finished now. So we'll, I'm not finished with the answer, but I'm just finished with as much as I want to. So this will be like something like, that's it there, right, isn't it? And then this one here is like something like this, right? So that's where they kind of, that's where they contact. Okay. So when they hit each other, they have a height of h. We're going to call that distance there x. So this distance here would be d minus x. So let's put all of those in. So this one here would be h. This would be h, and this would be h. And this one here is going to be like x, and this one here is going to be d minus x. So, and then obviously, sorry, this one here is equal to like minus u cos 64, and then is equal to u sine 64. Now I'm going to send the solution to this one just into the WhatsApp group directly after, and I'll send these slides exactly after. But my argument to you, and this is what my argument to you is, now that we've done all of this work here on this page, the question is kind of like there isn't any more information that we can put in here, right? And we have to use these formulas here. So I'm not going to say the question is kind of done, but it's like the hard part of the question is kind of done. Where is it? It's gone somewhere. So probably what's going to happen is that we're going to be able to write down an equation in, like, maybe take this one here, right? So we'll probably be able to write down an equation in H and get H on its own on one side, probably using, what have we got? We've got U, we've got A, we've got S, and we have T, sort of, right? So we have, yeah, we have those things. So we can basically write down a formula in S is equal to UT plus a half AT squared. And then we'll probably get something out of that that we can put over here. And then once we put that over here, we'll have an equation with U and its own on one side, right? So it's sort of like, and I'll just finish with this point. It's kind of like basically you've been asked here about something kind of apparently random, like show U is equal to 28. It's not like even clear, like, you know what I mean? That's, you know, it's not obvious that that would be something that would come out of this. However, essentially what it's basically what this U is equal to 28 thing is if you set up the problem in the way that I've done here, and then you just apply this formula here, one of the first unknowns that will pop out, one of the first things that you come across will be this U is equal to 28. Okay. So that's basically how it's gonna work. So okay, so then if you're happy, then I'll go on with connected particles then next week. But I'll probably just ask beforehand in the group. And if you want to do more of these projectile questions, because we still have a bunch more, and it might be worth the time.